Hi everyone, I'm MoML and in today's video we'll be discussing how to select the best threshold for our models, specifically for the simple binary classification case. I will be leaving the multi-class and multi-level classification cases for another video. The main question we'll be addressing is given the probabilities of some model where we should put a threshold such that if the predicted probability is higher than this threshold, then we label the sample as positive. And if the predicted probability is lower or equal to this threshold, we label the sample as negative. Should we put it here, here, or we are right the first time and we should put it here? That's no easy question to answer, so let's explore our options. First of all, I would like to emphasize that usually the threshold selection is more of a business problem than a data science problem. Why? Because ultimately, the business problem we are trying to solve dictates how many mispredictions we are allowed to have. Let's see what I mean by that. Suppose we are building a model to predict the probability of having an illness. In this case, we would prefer to select a lower threshold to reduce the chance of missing a patient who is ill. Even if our predictions may be a little too sensitive and produce too many false positives, we can always mitigate false positives with further medical tests. On the other hand, if we are building a model for helping us in hiring a new employee, then most likely we would want the threshold to be set quite high since recruiting a bad employee is usually rather costly for the company. So the new hire better be a good match, even though in the process we may have rejected many good candidates. These two examples illustrate how the business problem influences the threshold selection process. And trust me, there is a broad spectrum of modeling problems where we have to vary the threshold, even if it affects the overall accuracy of the model. Now, let's delve deeper into this topic and see how we can better quantify this idea. One of the tools we can use in our data science toolkit when dealing with the threshold selection problem is the Receiver Operating Characteristics Curve, or ROC Curve for short. If you are not familiar with it, let me give you a brief explanation of what it does. The ROC curve measures for a range of thresholds the true positive rate, which is the number of positive samples we correctly identify as positive, and the false positive rate, which is the number of negative samples we incorrectly classify as positives. To put this statement a little bit more into perspective, let's say that this group of points represents all the positive samples within our dataset. Of all these samples that are actual positives, some of them were incorrectly classified by our model as being negative. The metric which measures how many true positive samples we were able to identify is the true positive rate we mentioned previously. On the other hand, when looking at the negative samples, some of them were classified as positive by our model, the false positive samples. The metric which measures the percent of false positive samples in our prediction is the false positive rate. When we compute the ROC curve, what we do is start from the highest possible threshold of 1, where all the samples are classified as negative, resulting in both the false positive rate and the true positive rate being equal to 0%. We then slowly decrease the threshold and, as we do this, we observe that the true positive rate increases by a significant amount while the false positive rate remains rather low. As we decrease the threshold further, we notice that the true positive rate continues to increase, but at a slower pace, while the false positive rate starts to increase at a faster rate. If we decrease the threshold even further, the false positive rate increases rapidly, while the true positive rate slows down significantly. Eventually, when the threshold is set to 0, we predict only positive labels, resulting in 100% true and false positive rates. Most of the models behave in this way, where at a high threshold, the model predicts only negative samples, and as we decrease the threshold, the model begins to find some positive labels and is quite confident about these predictions, resulting in a low false positive rate. We then enter a phase where the trade-off between the true positive rate and the false positive rate is quite similar, followed by a phase where the threshold is so low that the model is not very confident about its predictions, resulting in labeling many negative samples as being positive, but also barely missing any true positives. So, given all this information and going back to the two problems presented at the beginning of this video, we would want to select a threshold for the disease detection model somewhere around here, and a threshold for the hiring model somewhere around this part of the ROC curve. If we don't have any business information regarding how certain we want to be about the model predictions or how much we want to find all the positive samples, the way I like to select the threshold is to take the one that maximizes the difference between the true positive rate and the false positive rate, which usually ends up in the middle phase of the ROC curve. I would like to dedicate the last part of this video to talk a little bit more about the ROC curve. In addition, to help us in selecting a threshold, the ROC curve can also give us an idea of how well our model performs. For instance, if our ROC curve were to look like this, where the decreasing threshold results in an equal amount of true and false positives, then we would conclude that our model is not very good because its predictions are no better than random guessing. On the other hand, if our ROC curve looks like this, then we've got ourselves a perfect model. However, in most cases, a model's ROC curve will fall somewhere in between these two extremes. If the ROC curve falls outside this range, this would most probably indicate a data labeling issue, and that the model is predicting the opposite of what it should be. But sometimes, even after comparing the ROC curves of different models, it's difficult to determine which one is the best. In these cases, we can compute the area under the curve, or AOC in short, for each model and compare those numbers directly. In general, a random model would have an AOC of 0.5, while a perfect model will have an AOC of 1. The AOC of most models will fall somewhere between these two values. And that concludes the video for today. I hope you found it helpful and informative. If you enjoyed it, please don't forget to hit that like button. And if you didn't, please let me know why in the comments section below. Also, if you want to stay up to date with the latest videos, please consider subscribing to my channel. Thanks for watching, and I will see you in the next one. Bye bye!